Hello everyone, my name is Saili and my roll number is 37. And welcome to this video on regularization techniques in machine learning. We will be exploring and studying laser ridge and elastic net in detail. So let us get started. First of all, why? Why do we need regularization and what is regularization? Regularization is such a critical topic in machine learning and deep learning. Imagine you are preparing for an exam. If you just memorize the textbook without understanding the concept, you will fail when faced with new questions. This is exactly what happens in machine learning, a problem which is called as overfitting. An overfit model learns the training data too well, including all its noise and outliers, but performs very poorly on unseen data. It has low bias and high variance. Regularization solves this. It acts as a coach that forces the model to focus on core patterns, preventing it from becoming overly complex. So ensures our models are robust, generalized, and reliable in real-world applications, from healthcare diagnostics to stock market predictions. Moving on to the next point of this. So, what is regularization? It in simple terms, it is a technique that adds a penalty term to the model's loss functions and discourages complexities. Let us break down this into mainly three types, which is ridge regression, ledger regression, and ElasticNet. First, the ridge regression is also called as L2 regularization. It adds a penalty equal to the sum of squares of model coefficient. This technique shrinks the coefficient but does not eliminate any features. It's like telling a model you can use all the features but do not let anyone become too dominant. Laser regression is the second regression. It is also called as L1 regression. Its penalty is equal to the sum of the absolute values of coefficient. This is more stringent. It can force some coefficient to become exactly zero, effectively performing feature selection. It tells the model figure out which features are most important and ignore all the rest. And third is ElasticNet. This is a hybrid approach between both L1 and L2 penalties. It is designed to balance the state of the ridge and lasso, which is especially used in dealing with datasets that have many correlated features. Moving on to the next topic, what is the mechanism or how it works? Now let's say it all comes down to the loss function. For a standard linear regression, the model's goal is to minimize the residual sum of squares, or it is also called as RSS. In ridge regression, the ridge regression modifies the new loss function, which becomes RSS. The formula is given on the screen itself, the slide itself. Here, the lambda is the key of parameter that controls all the strengths of the penalty, and higher lambda means a stronger push or smaller coefficients. The second is laser regression. Laser regression uses different penalties. The formula shown over on the slide is the formula of laser regression. The absolute value function is less forgiving than the square function. It also allows the optimization process that is completely zero out of the coefficient or less important feature. Third is ElasticNet. As it combines both L1 and L2 penalties. Here we have two parameters to tune, which gives us a fine-grained control. In practice, how we have to choose the mechanism. In Ridge, when you believe the most features are relevant, Lasso is used when you suspect only a few features are important and want simpler model. ElasticNet is used when your features are correlated and you want the stability of Ridge with feature selection and Lasso. Moving on to the next point, what are the challenges and the limitations of this point? So, while these techniques are powerful, they are not even without their limitations. There are some limitations like Ridge's main drawback is that it keeps all features in the model, which isn't ideal for very high dimensional data where feature selection is needed. The second is Lasso can be unstable. When multiple features are highly correlated, it tends to arbitrarily select one or ignore the others, which might not be optimal. ElasticNet throughout powerful introductions of more complexity, tuning two parameters, that is lambda 1 and lambda 2, as shown in the formula on the previous slide, instead of 2 requires more computational powers time throughout the cross validations. It's also crucial to remember that the regularization is a tool for controlling the model's complexity. It cannot fix the problems caused by poor quality of data or fundamentally flawed model architecture. Moving on to the next point, which will be the last point of this presentation, the summary and the conclusion of this topic. To summarize, regularization is a fundamental toolkit building effective machine learning models. Ridge regression shrinks the coefficient, Ledger performs automatic feature selection, and ElasticNet provides a robust middle ground. Mastering these techniques allows us to create model that not only performs well on paper but also in real world. As AI continues to evolve, the principle of regularization will remain essential and developing efficiently. Irrepeatably and trustworthy models will be coming our way. Thank you for watching.